So today we're going to discuss framing, and there's actually several tools in Vectorworks that help with framing. So there's actually a couple of different files that I'll be uh, sharing with you and showing some framing solutions and how the Vectorworks tools are helpful. So this first one here is a little house I did here in East Austin a few years ago. And I may have shown this before, I don't recall, probably. And the design intent was to have this really flat sort of roof that would serve as a front porch, and then it would continue and cantilever out and be a carport, and then it would also cover the screen porch. And the initial design had been for steel. I think you can see why this is something that would certainly lend itself more to steel framing than wood framing. But as is sometimes the case, there were some budget concerns about that. And so we tried to find a wood framing solution. And thanks to the work of the structural engineer on this project, who's Michelle Weinfeld, who's actually a Vectorworks user, although she's really working as an architect now rather than an engineer. But at the time, to my good fortune, she was still working as a structural engineer. And so it was really helpful to be able to pass this model around back and forth. So there's a kind of an intricate set of cantilevers and double cantilevers that are going on here. So let's see if I can pick something. There we go. So I'm highlighting this beam, and I'm going to go ahead and select it and use my clip cube just to be able to isolate it. So so this beam is buried in the wall, and then it comes and it cantilevers out. You can see how it's doing that, right? And then the object itself is just a solid subtraction, but it's a solid subtraction that includes a framing member as one of the components of the subtraction. So the framing member, which I'll get into a little bit more detail, can serve as a beam, it can serve as a rafter, it can serve as a joist. You can make floor trusses with it, a lot of different applications for this tool. It lives in the detailing palette, and it's this tool right over here, framing member tool. And so one thing that you may not be aware of, or you may, I don't know, is that you can go ahead and use tools like the framing member tool as part of a solid subtraction. So in this case, I just had a little extrusion here that I'm highlighting that was sort of matches the pitch of the roof, so that I could essentially clip off the very top of that beam so that it doesn't stick out above the roof plane, right? You can see that there, even though everything's sort of ghosted in. So it's registered to the underside of the plywood decking in this case. And so it still reads as a solid subtraction, but if I need to go back and change the depth of the beam, you know, if instead of 16 3/4, it needs to be a different depth, or if we need to change it to a 5 1/8, right? We can do that as a framing member, and then it remains a solid subtraction, and it's still sort of buried in the wall. So anyway, that beam was there to carry sort of the primary load. So there it is. And then next, there is another beam out here, right? Let me go ahead and use the clip cube to isolate that. And so that's just spanning from the corner of the building, so it's just supported on the building itself. And then about 2/3 of the way along its length, right over here, you can see where the pre-selection cursor is highlighting the first beam that I just showed you. That beam is carrying this one. And so everything to the right of this beam that I've just selected is a cantilever. So it's a sort of a classic double cantilever. So first this one, and then that one, and then the rest of the framing just sort of follows along. And I think it's pretty straightforward after that. So, so what was nice about this is that we could sort of start off with the overall assembly. Let me go ahead and turn on some roof classes here. So I could just model this this roof structure, and because the overhang is different, the overhang is different on different sides, right? So it needs to be one overhang at the carport, and then it's a different overhang at the front porch, and then it's another overhang. So if we look at it in top view, there we go, or even in top plan view, and if I select this, the roof object, you can see that these ridges are not at 45-degree angles because each of these faces is at a slightly different pitch. So that was just initially modeled with the roof tool. Right, so these are just individual roof faces, but at some point it was a roof object. And then that gave us the boundaries so that we had a level fascia, we have a level condition where it meets the building, and then the slopes just get adjusted to be whatever they need to be in order to make all of that work. So that, as I said, it sort of reads as this fairly flat sort of structure. So a little later, I'll show you how to develop an automatic way for developing roof framing from roof models. But this is a kind of a good example of using the framing tool and clipping it in order to be able to solve a structural problem within a fairly tight volume or space. You know, obviously we could have made this structurally easier by making those roof pitches steeper, but of course the steeper that it gets, the farther and farther we're getting from the original architectural intent, which was to have this sort of flat roof. So all sorts of framing members go into modeling this. And again, this was sort of a luxury because I could just pass the Vectorworks model over to Michelle, the engineer, and she could pass it back to me, and we could sort of go back and forth. And that is obviously not always the case. Sometimes I just get 2D DWGs from engineers, and then if I have a tricky situation like this, then I end up replicating their model by using framing members. But this is a great example of how this tool is really quite useful. That's anybody have any questions so far on that? If you do, just unmute yourself.
Yeah. So when you're doing the roof, you talked about the fascia almost as the last thing you added, but wouldn't the roof framing or the roof tool need that fascia as a place to sort of reference? You know, you put a top boundary and a bottom boundary, and that would be like, in other words, the top of a wall. Isn't that how the roof would actually, the model be built, is to that roof fascia?
Yeah, so initially it was just the initial architectural model was just the roof faces themselves, which obviously have a fascia. And then once we figured out that we had enough depth to make this work, then I went in and modeled an additional fascia object. Again, the one that I've just highlighted you can see, if I look at that, show you the object info file, it's reading as a framing member. So that if I do turn on the roof class, you can see there's a little bit of pixelation because my framing model fascia is superimposed with the roof fascia. So the roof fascia is this kind of gray color. And then you can see as I'm moving around, those two models are coexisting in the exact same space. And so you get this funny sort of pixelated rendering. That's what's going on there.
So there's no way to substitute the fascia that was included in the roof model and just substitute it for a beam or turn it into a beam? Suppose they're superimposing another framing member.
Yeah, no, you can, but then the roof object is still there. So when you frame a roof, it doesn't explode the roof and replace it with a framing member. It uses the roof as a guide to develop a framing model. That'll be more clear when I demonstrate it a little bit later.
That makes sense. I understand.
And if you do add a fascia to the roof object has a fascia feature, which adds a fascia on top of what is essentially a subfascia, right? So if I were to build this roof today with the roof object rather than roof faces, I don't remember why I devolved it into roof faces, but I would probably add a fascia, and that's actually sort of realistic. Oftentimes there'll be a structural fascia of maybe a 2x10 or something like that the engineer will require, but that's not necessarily very sightly, and so I might add a 4/4 fiber cement fascia over that sort of structural subfascia. Make sense?
Thank you.
Yeah. Okay, so that's, I think you can see the value in using the framing tool for this kind of detailing, as opposed to just doing a bunch of extrusions. Because with the framing tool, you can set the pitch as an angle, you can notch it, you can do some of the basic, dare I say, sort of carpentry tools like bird mouthing and so forth that you would do to a normal piece of lumber when you're framing. And you don't have to resort to just a bunch of extrusions. So if you can, try to use a framing member or its sort of more evolved version, which is the structural member, which can serve as both columns and framing to do this kind of structural detailing.
And wouldn't that also reduce the file size by using the tool as opposed to doing extrusions?
Yeah, probably not, but I don't really care about file size these days. So I don't think it would. But yeah, my primary motivation is the ease of modeling and the ease of making changes to the model. I may be overvaluing myself, but my time is more valuable than file size. All right, so let's see. So if I want to do some generic framing, these Zoom controls always get in the way. If I want to do some generic framing, I've got some other options. So something that I'm generally a fan of and that doesn't always work out on every project is advanced framing. I've probably brought it up in some of these meetings before, which is a technique you developed actually in the 70s, if I'm not mistaken, to use less lumber and to use it strategically in order to be able to have more insulation in your wall assembly. So this is just a diagram that I pulled off from, I think, the Department of Energy website, and it originated with the Building Science Corporation, Joe Steebrook's outfit. Really great resource, and it sort of diagrams out some of the properties of advanced framing. I will say that the tricky part about advanced framing is not any of the framing techniques. It's, in spite of its name, it's actually quite basic and straightforward. the tricky part is that everything has to line up in order for this to work. So if you want to get away with a single top plate, your joists or your rafters have to fall on a stud. And it's sometimes difficult to get buy-in from framing crews. And so you really need to make sure that you've got 100% buy-in from the general contractor and the framing subcontractor in order to be able to pull this off, because as we all know, framing just happens so quickly. You know, if no one's on board by the time you figure that out, it's too late. So these are some of the characteristics of advanced framing, and I'm not going to spend any much more time reading over that. You can look into it if you're not familiar with it, or use this as a refresher. But there is a wall framing tool in Vectorworks that I want to talk about. So in this project, for example, what I've done is in this save view, I've just isolated all of the exterior walls. So this is a real world scenario that I've had a few times where I've wanted to investigate either for my own knowledge or for the benefit of a client who's maybe skeptical, or a contractor who may be skeptical of what the benefits are of advanced framing over conventional framing. So classically, advanced framing would use 2x6 studs instead of 2x4, and you would space them at 24 inches on center instead of 16. There are other features, but those are two really important ones. And the idea is that you put less wood in your wall assembly so that you can have more insulation. So I was sort of faced with having to try to quantify what the lumber cost differential would be if I advance frame a project versus traditional framing. So, you know, you would think, well, you know, if I have fewer studs, but the studs are more expensive, it's probably going to be a wash. But, you know, you really need to figure that out in some cases. So the wall framing tool lives in the AEC menu, and it's under framing. And I'm going to actually kind of flip over to another file. Can you guys see this other file?
Yes.
The screen porch. Okay, great. Thank you.
Yes.
Yeah, I don't always know with Zoom if I switch in a window, if that window is showing up for viewers. All right, so here's a little model, and I just want to walk you through the framing process. It's actually pretty straightforward. So under the AEC menu, you go to framing, and you'll see that there's a wall framer command. And you'll want to give it a distinct model name. And you might do this, for example, if you're looking at some alternatives, for example, conventional framing versus advanced framing, right? So I'll just call this, you know, frame model 1. Great. So I'll create that. Oh, sorry. So too long. Frame 1. Okay. So there's a couple of things to see in this dialog box, which is maybe not quite as straightforward as it might seem. So the framer can produce a 3D model. It can produce a 2D model, i.e. a series of elevations, wall by wall, panel by panel, how you would actually frame this. And it can also produce some worksheets, which would be very useful for quantity takeoffs. I really think of this as a design tool rather than as I'm going to hand this off to it's really a design tool for me. It's not necessarily a construction documents tool. I'm not necessarily going to hand off a whole series of elevations and tell the framer how to frame a project for a couple of reasons. Obviously, liability, but more importantly, I'm not a framer. so so it's a bit much for me to tell the framer, how to do their job. So rather, I think of this as an opportunity for me to quantify some different scenarios as an internal design tool and compare one design to another, for example, and see what the ramifications might be. I think that's the real value here. Anyway, so for the sake of argument, I'll do the 2D model and the 3D model and the worksheets. But fundamentally, at the end of the day, really what I'm most interested in are the worksheets. And the 3D model looks cool, so that's nice. So I can specify what framing output that I want: 3D model, 2D model, worksheets, any 1, 2, or 3 of those. And then I need to tell Vectorworks what layers to frame from. So I've got a little bit of wall on the roof layer, and I've got some wall on the floor 1 layer, so I definitely want those. And then I'm going to click over here on options. And this may not be immediately obvious, but the first thing I want to do is create a new wall class. It says default. And I confess, I don't really know what the default is, but when I try running it with just the default, I'd get nothing. So I'm going to go to new, and the classes are not necessarily fully in alphabetical order, but luckily I can just start typing. You see, I typed WAL and it came up with the wall. And so I could frame the wall exterior, the interior, right? I have different wall classes. So it's going to look for walls that are in the wall exterior class. And that's the one that I want. And here, this is fairly obvious, the dialog box. These are all the parameters of that the framer is going to use to build the framing model. So what is the default stud spacing? What's the maximum plate length? What width is my sheet stock? What width is my sheet stock height? So maybe I can get a hold of some 4x10 OSBs instead of 4x8s, right? So I can change all that. And then I can define whether the lumber is 2x4 or 2x10 or 2x6 or 2x8. And I can create some new ones. So there's some 2x3 framing requirements in some cases. So I could go ahead and add that. I'm happy with 2x4 for today. And then I can specify whether there's going to be fire blocking, whether I do a double end stud, a double top plate, a double bottom plate, and so on. So I'll go ahead and do the double end studs and the double top plate and the fire blocking, of course. And so those are the parameters that I have control over. Now notice that I'm telling it how to frame this wall, and I'm stipulating the lumber size. And that's important because if, for example, you were doing a project and you were on the fence as to whether you wanted to do conventional framing 2x4 at 16 on center or advanced framing 2x6 at 24, you might think that you would need to create 2 separate models of your building, one with a 2x6 wall and one with a 2x4 wall. But that's actually not the case because the framer just looks at the overall wall and it approximates the framing of that wall, and you can stipulate what the lumber dimension is. So in other words, I could have a 2x4 wall that's a wall style that has 3.5 inches of framing in it, and I could still run the framer module or the framer tool and tell it to frame that with 2x6s or 2x8s or whatever. So so keep that in mind, that you don't necessarily need to build an alternate model for each stud size that you want to experiment with.
Francois, if
Yeah.
you have a situation where you're going to be using part of the building will be 2x4 and the other part of the building will be 2x6, can you use the wall framer for 2 different wall types?
Yeah, you would probably need to class those distinctly, right? So here I'm only interested in my exterior walls because it's a given that my interior walls are going to be 2x4s. I mean, they are what they are, right?
I meant all exterior framing that.
No, I get it. Yeah. I'm just saying in this model, I don't have a separate class for 2x6 walls versus 2x4 walls. They're all just in the wall exterior class. But if you knew that you wanted to do some walls as 2x6 and some walls as 2x4, for example, you would want to develop a different class ahead of time and class those walls accordingly, because it's using the wall class to tell it what to frame.
Got it.
Yeah, good question. So I'll hit OK, and I'll go ahead and hit OK again. And it does its thing. And so if I open up this worksheet, and can you guys see the worksheet that just got thrown up?
Yes.
Great, thank you, guys. Right, so you can see it's gone ahead and it's listed, it's created a bunch of different frames, right? So each frame is a panel. So frame 1, frame 2, frame 3, frame 27, and so on and so forth. And it's gone ahead and given me a length for all of these things, and eventually I get a total linear foot of plate stock, and it breaks it all down. So so my total, you can see my total linear amount. So I might need a little bit of formatting to kind of clean up this worksheet so that it's a little more presentable, but it's giving me essentially a lumber takeoff, which is kind of cool. So that's the worksheet model. And then let me close that. And then you can see that it's created a couple of new layers. Right over here, here's frame 1, 2D elevation. I'm going to go to view and make my active layer only. And so you can see that it's gone ahead and drawn a nice elevation of each of these walls, the end wall, right, the side walls, the little dormer that I have up there that I built with walls on the roof layer. So it's laid it all out for me. And again, I'm probably going to refrain from handing this off to a framer, right? But it's useful information potentially for how this might go. Notice that it's not an engineer, so it's not sizing, headers for you, anything like that. And then it's also giving us a 3D. Let's see. Oh, and then there's the frame 1 model itself. And so you can see that it's, it's done a reasonable job of framing all of that. So, I could probably pick a few, have a few bones to pick with how it frames this. And again, my goal here is not to have a stick by stick model that I'm going to turn around and actually build from. As I said, this is, for me, it's a design tool. So I can explore what happens if I frame to my lumber order, if I frame this with 2x4 versus 2x6, for example, with different spacing. And so back over here, that's what I did in this other model. I just ran the framer, and here you're seeing it superimposed over the architectural model. And then, so this is the conventional framing with the 2x6s at 16. Here's the advanced framing version. You can see it's a little bit different. 2x6s at 24 with just a single top plate. And then I also got these worksheets that I just kind of condensed down. So I did a little bit of formatting and tabulating. Took me a couple of minutes to do that. And so I could see that, 2x4 at 16, I end up with, 388 10-foot studs. At the time, this is probably some time ago, they were $6 a stud. So that's about $2,400 in lumber. And the 2x6 wall at 24, I get 317 10-foot studs. And of course, there's 2x6 studs, so a little more expensive. So my lumber bill is, at just a hair over $200 more for doing the advanced framing. And in fact, I built a case like this for a client once and they ended up they ended up rejecting the advanced framing option because they said, well, now that I've got these 2x6 walls, aren't I going to spend more money on insulation than with the 2x6 wall? To which I said, no, that is exactly the point. I want you to spend as much money on insulation as humanly possible, because this is Texas and it gets hot. But they didn't buy it, sadly. So, you know, you win some, you lose some. But this is really cool, I think. If you're ever in a situation where you need to build a case in order to convince somebody to do it one way or the other, or just to see for yourself if it's worth doing. This is, I think, a great tool. Any questions about that?
So Vectorworks doesn't have a tool that does a cost analysis of energy cost save over a period of time between 6-inch and 4-inch walls, because we had done that. There was
that's next month, Bill. Next month we're going to talk about Energos, which is the energy analysis tool that's baked into Vectorworks.
Oh, okay.
So yeah, you could totally do an analysis of what the relative, I mean, theoretically, what the relative energy cost is for, say, an R13 versus an R16 wall.
Cool.
Yep. So, got to wait for next month for that one. Okay. Any other questions? I mean, this is, you know, this is really quick. You saw how quickly it calculated. Now, granted, this is a small project, but you can, you know, this tool is fast enough that you can just do it to your heart's content on your model, and then, you know, extract the information that you want and discard it if you need. Yep. Sorry, somebody was going to say something.
Yeah, so when you have this model all finished, if for some reason or other, like right now, I'm doing a situation where I need to have one set of studs be at a different dimension. In other words, moving one of those studs over, can you tweak the position of any one of those studs in that model, or is that just doesn't work?
No. No, I mean, you theoretically you could, right? If I click on one of these studs, it's just an extrusion. So yeah, I can edit this model if I really wanted to, but I'm going to show you another technique for framing that might be a little bit more user friendly to that. It's not as sophisticated in terms of the quantity takeoff, but for some applications, it might be more appropriate than doing this. Yeah, so the model's not. I mean, it is theoretically editable. Each of these objects is an extrusion. It's in its own class that Vectorworks creates automatically. So yeah, you could play with it if you needed to. But again, my intent is not to have a total high fidelity stud by stud model that I'm going to build from. I'm using this as an analysis tool. So a certain amount of coarseness or inaccuracy in the particular framing is fine by me. So if I go back to this view here, I can also do roof framing. So this little roof is just a hipped roof, right? Made with the roof tool, and you can see obviously it has different pitches on two faces. Seems to be a theme today, is different pitches on roof faces. And so also under AEC, you can see under framing, there is a roof framer tool. Now, I think I only get to select that tool. Let me deselect the roof if I have a roof object selected. So you can see it's now grayed out. So I have to select my roof. I can select the dormer roof too. I think that'll work. And go to roof framing, and there's my roof framer. So the roof framer allows me to either frame the entire roof. So if let's say I just started out with a generic 6-inch or 8-inch roof model, and I didn't differentiate it by components. You could just use the whole roof, or you could use the component. So in this style, I have a component for the roofing itself, for the decking, for the soffit, for the ceiling, and for the framing. So I would just go ahead and pick framing, and it would register to that. I can create all of these different kind of objects, rafters, collars, plates, and so forth. So I need to create rafters. So there we go. They're probably not going to be 2x4s. They're probably going to be 2x8s. And I can specify a minimum spacing, say 19.2 inches, right? And I can set the top of the rafters to the top of my framing component of my roof style or to the bottom. I think I've already planned this roof style to be for 2x8 framing, so it doesn't really matter. And I can match the rafters across hips and valleys so they match or not if I don't care. And I can put them in a particular class. So here are all my classes, some of which are actually invisible. And so let's go to structural. Well, I tell you what, let's go with I don't know where my structural beam wood went, but I'll just pretend like we'll just use this steel class. Or I can go right to my classes menu and I could create a new class. Like, let's go ahead and do that. So I'll create a new class and I'll call it structural framing roof. Okay, and make it visible. And I'll give it some kind of wood kind of color and so on and so forth. Great, that's good enough for now. We can tweak it later if we feel like it. So there it is. So I'll put it in the structural framing roof class. Right, click on object attributes, and I can just go by class style for all of that. So those are my rafters, and now I can go ahead and decide on collars or not. Plates, well, the plates are already part of the wall framing, so I probably don't need to model that. But I could model purlins. In this case, I've got decking, so I don't need that. I could model ridges, right? So those maybe are going to be 2x10s, flush to the top of the rafter. And likewise, I'll put that in the same class. Okay. And all attributes by class. Headers, hips and valleys, right? The whole 9 yards. So probably do those as top, framing roof, class thickness, and so on and so forth. So having done all of that, I'll hit OK. Vectorworks is doing its thing. And you can see that I've got 46 framing members. I'm going to go ahead and group those so that we can see them. And then let's go into the group. Oh, it looks like I'm missing a couple of things. Wonder what happened here. Interesting. I think it kind of got lost with the cutout that I put in the roof. I think that's probably what threw it. So I might need to fix this manually, or perhaps run it again. But if I look at one of these things, you can see that this is the same kind of object. So unlike the wall framer, which just creates extrusions, what the roof framer does is it creates a series of framing members, just like the ones that I showed you at the very start of our meeting. So in this case, It's 1.5 inches by 7.25, so it's a 2x8. It's called out as a rafter type. It has a bearing inset of 3.5 inches. It gives me an overhang based on the roof geometry. So you can see it's done a little bit of bird mouthing here to sit on top of the plate, and so on and so forth. I'm not really sure why it didn't finish this roof, but you know.
When you do this framing of this roof and all the things, and then the Vectorworks sees it as one object. But you went to the object info palette and it pulled up the whole thing.
No, it creates a series of framing members.
Right.
I just grouped it just for the simplicity of showing it to you without seeing the whole model.
I thought it did that before you grouped it.
It did, but it created a series of framing members. It didn't create one object, it created, 43 or whatever framing members. So I can take these two and I can just duplicate array. I shouldn't really have to, but I probably need a couple more. I was just guessing on that one. And then if I really need to, I could just take all these and distribute them and so forth. So yeah. Yeah, so I think so that I may need to go and edit out that dormer and so forth. I'm curious. I'm just going to run this again. I'm going to go into this roof and I'm going to delete the rectangle that I used to clip that roof. So there's no more hole for the dormer. And let me try this again just to see what happens. I'm going to go ahead and delete this model.
Can you clip the roof after the framing to clip the framing model?
I'm sorry, what?
Can you clip the roof after you've done the framing so it clips the framing model? It will clip the framing model?
No, the framing model is not dynamically linked to the roof. So if I change the roof pitch, right, one of those roof pitches is at a 612. If I decide, no, I want to make that, move the ridge over and make it a 5/12, it's not going to edit the model. I just need to run the command again. So clipping out the dormer hole isn't going to have any effect on. I'd have to do that manually. Yeah. So as I suspected, that was the problem. It didn't know what to do when it met my dormer. Right. So if I've clipped the roof, I may need to go ahead and model it unclipped, and then go back and edit the framing model. So this is cool. It has certain benefits. It's very useful if you want to produce a detailed model to check for collisions and so forth. Or if, for example, you wanted to not have a soffit but have exposed rafter tails for your roof and so forth. This is a nice technique for achieving that. But what it doesn't do, unlike the wall framer, is it doesn't generate any elevation views for you. It doesn't generate a bill of materials. So it's really a modeling exercise rather than a quantity takeoff. Now, obviously, you could build your own worksheet and ask Vectorworks to give you the total length of all of your framing members that are in a particular class and so on and so forth. So you could go ahead and do something to develop some quantity takeoffs based on this model, but Vectorworks isn't doing it for you out of the box.
Francois, could you show me again the distinction between the tool that gives you the worksheet and the tool that does not give you the worksheet?
Yeah, so the tool that gives you the worksheet under AEC is the wall framer.
Yeah.
So it's just for walls.
Oh,
And the tool that doesn't give you the worksheet is the roof framer, and it's just for roofs.
oh, why, why doesn't the roof framing give me a worksheet?
Because the software engineers didn't do it that way.
Okay,
But you can send an enhancement request to Vectorworks.
okay. Seems pretty obvious.
These two tools they're several revisions apart. Like the wall framer has been around
Yep.
much long time before the roof framer. So you know, they were just developed at different times with different criteria.
Interesting.
So that's roof framing.
Hey, Francois,
then-
can I interrupt for a
Yeah,
question?
please.
Because Bill's comment made me think, well, you could do a custom report. I even took a quick peek to see if there were any pre-formatted reports that you could query your model for framing members, and that could give you takeoffs and such quantities. But then I also wanted to ask, remember the framing member, the cantilever that you showed at the beginning of the session? Will it find those framing members that are embedded in some of those solid subtractions?
Yeah, that's a great question. I don't know. I don't know if it would or not.
Something to experiment with, I guess.
Yeah. Did you see, is there, I mean, that's how I would approach this. I would just do a report in order to report all the framing members that are in the, you know, roof framing class, for example. I don't know if there's a pre-baked report. That would be under tools, reports, create report. And then here's all the reports that Vectorworks has. Let's see if there's a rack frames report. That's probably not it.
Material takeoff by category, perhaps.
Oh, material by architectural object. Wonder what that does. Okay, so that's walls, slabs, and columns. Oh, and structural members, but not framing members. So that's close.
I suppose you would have to do a custom in that case.
Yeah. Yeah, and this one, the material takeoff by category is like a CSI category, and that's based on using the material attribute of an object, which, you know, you could add materials to framing members. But I think that's designed to work hand in hand with materials.
Francois, I may have missed it, but when you're in the roof framer palette, there are all sorts of aspects that you can control. I don't remember seeing a tab for soffits.
There isn't one.
Huh. Would that be best to be included, or am I missing something?
So, yeah, soffits are sheet goods, of course. And so it doesn't do like plywood or decking. It just does dimensional lumber.
Yeah, but sometimes you have I don't think what they're called, the horizontal members that go back if you want a flat soffit, and that would be a small framing member. Goes
Correct.
back.
Yes.
So I guess you just have to put that in manually, or it's just, I don't know.
Yep.
Why I'm surprised not to see it, that's why.
Yep. It's assuming that your soffit is, you know, to the underside of your
Rafters.
rafter. Yep. And, you know, the nice thing about it's all kind of a give and take, right? The nice thing about the roof framer is that because it is using these framing members, you can sort of elaborate on the model by adding your own framing members and then just array them. It's not automated, but you know, you can use this as a starting point to develop a pretty intricate model. It also, by the way, is paying attention to how you've treated the edge of your roof. So I did not do a plumb cut on my roof, and you can see as these rafter ends are butting up against my, you know, sort of stub fascia here, you can see that it is following the profile of the roof that I've stipulated. All right, so then the last thing I wanted to throw out there is an alternative technique for wall framing. So this is a little shed I did some time ago, and it looks like I did this with the wall framer, but I didn't. Each of these panels is if you look at that, you'll see that it is actually a wall. So this is a very small project. It's a shed, as I said. And so I had the luxury that I could actually go in and sort of think about this stud by stud, which is obviously not often the case. And so what I did was I created a curtain wall style.
Oh, yeah.
So the curtain wall style is obviously not intended to be for framing, but I just created a curtain wall that doesn't have any panels, and made the mullions essentially 2x4s. And so that's sort of what that looks like. And so the kind of the fun thing about that is that you can do something like you can go ahead and let's see, select these 3 studs, and then I can right click and on those and there you go, right click on them and then distribute the frames. So I can make them evenly distributed, which they already were. So there's, you know, nothing very exciting about that. And then the doors are just openings in the stud wall. And then what I did for these doors is it's a door style. Well, actually it's unstyled, but if you look at the door settings, you can see that I built a lintel. And that's how I did the header, is essentially with the lintel of the door style. Now you get a slightly unrealistic condition because obviously you wouldn't have a 2x and then a lintel on top of it. But anyway, that was sort of a little exercise when I wanted to get really picky about my framing, is create this curtain wall style. And then, you know, my vertical blocking, these are just there, and I just sort of moved half of them up or down by 1.5 inches so that, you know, you could end nail them, obviously, as you would expect. So probably a little bit overachieving here on that one, but thought that would be fun to share. Oh, I don't know what happened here. That's interesting. Oh, I got totally turned around. we go. And so these are just rafters that are just framing members that I just arrayed. So that's what I have for today on framing. Is any other questions, comments?
Maybe one extra question.
Sure.
Have you experimented with chain extrude for framing, for even if for like a study?
I have not. That's a great idea. I vastly underutilize the chain extrude tool. So that'd
As
be
do I.
something that would be something to think about.
Francois,
Yes, sir.
I recently designed a pergola and I just used extrusions
Mm-hmm.
for the, 2x8s or 2x6s or whatever I was framing with. And the problem with doing a model then is that when you turn it into a plan, the extrusions are transparent. So that you can't cover one thing up that's above another thing.
Right.
If I'd used framing members, would they have shown up as solids?
No, they would look from outside the extrusions once you. Oh, what you mean? If you were happy with the framing member, but you didn't do a subtract solid or anything like that, is that what you're saying? Yeah. If I go to top plan view here, you can see that these framing members they're hybrid objects. They have a 2D fill. So I could totally, select all of these and bring them to front, and they are going to mask something like
Gotcha.
I would expect that they. But if I go back to this guy, right? So this one that I showed you at the beginning, I'm just gonna group that and go into the group and go to top plan view. You can see that in top plan view, that is not, there's no fill going on there. If I send this to back, right? It's not masking that rectangle that I just drew.
Mm-hmm.
So if that's the case, what I would do is I would probably not on each individual one, but maybe a collection of them. Under AEC, I would create an auto hybrid in order for it to appear correctly in my 2D view and in my 3D view.
Right.
And so there, now it's an auto hybrid, and it looks right in top plan view, but it's still a 3D view. Now, auto hybrids are funny things because you can't create an auto hybrid from an object that is itself a hybrid object. So, for example, if I go back to this and I select all of these framing members and try to create an auto hybrid, it fails because the framing tools are already themselves, or the framing members are already themselves hybrids. So you can't make an auto hybrid out of a hybrid. But if you sort of dehybridized that framing member by clipping part of it with a subtract solids or add solids or whatever, like I did back over here, even though buried within that subtraction there is a framing member, you can create an auto hybrid out of that. So it's a bit of a workaround. So that's what I would do for your pergola guy is for it to appear correctly in 2D in plan view, is I would create an auto hybrid. The other option would be you could just manually create a hybrid symbol, and you could take your framing member and put it in or your extrusion, put it in the 3D part of the symbol, and then draw like a rectangle for the plan view of the symbol. But auto hybrid just does that quickly and automatically for you.
Well, I should have asked you first. Thank you.
Yeah, no worries. There are just so many tools, like Keith's mention of the chain extrude tool. It's like, it's easy to miss that one tool that would have made your life so much easier.
Yeah, I don't know that one. Where is it?
Chain extrude, I think that's in the 3D palette, isn't it? Or is it just a chain? Could just be a chain
Building shell.
of building shell. Oh yeah, there you go, chain extrude. Creates continuous and periodic extrusions of the selected polys along the path drawn. I'm not going to embarrass myself by experimenting with it live. I'll play with it and get back to you all.